Quartiles, 5-figure summaries, and outliers. You already know how to calculate the median, and that is the middle score of a set of data in order. There is another measurement that has relevance, and those are the quartiles. Effectively, the median of the bottom half of the data and the median of the top half. So very quickly, if we find the median of this set of data, we have 1, 2, 3. Oh, can't count. 2, 4, 6, 8, 10 scores. 10 scores means that half plus a half. Half of 10 is 5. We want the 5.5 score. So here the median is not one of the individual scores. The median is in fact 7. Now what this does is it separates our data into a lower half and an upper half. Please note that since we have an even number of scores, the median is not one of the scores, and so it's not included in the separating that into two halves. The quartiles are the median of the bottom half. So here, Q1, the first quartile, is 4, and Q3, the third quartile, is 13. So that in fact means that the median is Q2. Those quartiles separate the data into quarters. So what remains is 4 little sections of data there. This is quite useful because the two quartiles Q1 and Q3 let us calculate what is called the interquartile range, and it's useful for getting rid of the effect of any outliers in our data and just looking at how spread out the middle half of our data is. So the IQR, the interquartile range, is Q3 minus Q1, which in this case is 13 minus 4, which is 9. That is separate, of course, to the range, which is the top score, maximum minus the minimum, which in this case would be 18. So that has introduced you to finding quartiles. Now a 5-figure summary is 5 digits labelled, please. It's the minimum score, Q1, the median, which is Q2, Q3, and the maximum score. You would set it out like this. So this is the setup for a 5-figure summary. You put your little equal signs. And this is basically a summary, a description of our set of data. The minimum is 2, Q1 is 4, the median, third quartile, and the maximum. So if you're asked to create a 5-figure summary, please do not just write 5 numbers, 2, 4, 7, 13, 20. You must say down the page, minimum, Q1, median, Q3, maximum, and give your numbers. This is a 5-figure summary. Just very quickly, with an odd number of data points, 9 here, our median position is thus going to be the 5th score, 1, 2, 3, 4, 5. Because remember, that would be 9 scores divided by 2 plus a half. 4.5 plus a half is 5. I want the 5th score. Just a reminder of how we find which position is our median, which happens to be 5. When you have an even number of data points, then your median doesn't get involved in either of these halves. When you have an odd number of data points, then your 2 sets of data, in order to have 2 even sets, they exclude the median. There might occasionally be other ways of calculating it, but this is what we do. So our bottom half and top half of an odd numbered set of data excludes the median. So therefore Q1 is midway between these two. So Q1 is 2, and Q3 is midway between these, so it's 6.5. And if I was asked for a 5-number summary, that would be 1, 2, 5, 6.5, 9. But I won't bother doing another one. I think you've got the idea. We also have to look at the concept of outliers, remembering that any time we've got a set of data that's been collected from somewhere, and at times you might have a data point that's so far outside this data that it's not relevant or sensible to include it. For example, if you surveyed this group of people listening to this, including myself right now, about their income, I would be an outlier, and it would not be sensible to include me in that because I'm obviously different to the rest of the group. I'm really old. So we need to be able to mathematically quantify what is an outlier. Previously, in other years, we've just gone, oh, look, it's really far above or really far below the data set, so it's not an outlier. So it's an outlier. That's not really good enough. So let's take a new data set. Sorry, I didn't write it down before. And you can see we've got an obvious candidate for an outlier up here. But we do need to be able to mathematically quantify, is this an outlier? And we have formulae for that. So if an outlier lies outside these particular ranges, sorry, I'm just going to get the textbook to write, so make sure I write this down correctly. So if it's less than Q1 minus 1.5 times the interquartile range, or if it's more than, sorry about dodgy writing, Q3 plus 1.5 times the interquartile range. Now, up this end, sorry about my screen here, up this end of the data, we're going to be checking, is this more than the third quartile plus 1.5 lots of the interquartile range? So you see we need the quartiles in the interquartile range to work out if it's an outlier. We'd be checking, is this 1, is that less than the first quartile minus 1.5 lots of the interquartile range? So we'll do the working for those. I'll find some more paper. So we need to find our quartiles, 13 data points, which means my 7th data point is my median. Exclude the median from my sets here. So my quartiles are now 6, Q1 is 2, and Q3 is 5.5. So my interquartile range is Q3 minus Q1, which is 5.5 minus 2, so 3.5. Then, sorry, I got distracted. We need to work out these. Q1 minus 1.5 times the interquartile range equals Q1 is 2 minus 1.5 times 3.5. So, calculating that, that's negative 3.25. My lowest digit number is 1. Is that less than negative 3.5? No, it's not. So I have no low outliers. And then calculating the cutoff for outliers at the top of my range. Q3 plus 1.5 times the interquartile range. Q3 is 5.5 plus 1.5 times 3.5. That's 10.75. Do I have any scores above 10.75? Yes, I do. It's 18. Therefore, 18 is greater than 10.75 and can be considered an outlier. Sorry about no space there. So you need 5-figure summaries. You need to be able to find the quartiles, the interquartile range, and determine if a data set is an outlier. If a data point is an outlier.